In today's video, we'll be talking about in some common mathematical fallacy. So basically, through internet search, I find there are three different interesting fallacies. One of them is this, one of them is that, and one of them is below. Let's first talk about the first one. Can you spot the mistake between the two? From this graph, we see that x squared plus x plus y is equal to 0. So we divide both sides by x. X plus 1 plus 1 over x is equal to 0. The third step, negative x squared plus 1 over x is 0. The fourth step, the third step is because, go back to the first equation, x squared is equal to 0 minus 1 plus x. So, yeah. And the fifth step is going to be, and negative x plus 1 is going to be 1 over x. So, combine the two together, it's going to be negative x squared plus 1 over x is equal to 0. So we get 1 over x squared. X cubed is equal to 1 because we multiply both sides by x, and thus x is equal to 1. 3 is equal, then we get 3 is equal to 0. So, problem is that the problem of it is that the two solutions are both in imaginary plane. Due to that, its discrimination is b squared minus 4ac is less than 0. Let's try calculating it. We see that in the first equation, b is equal to 1, a is equal to 1, c is equal to 1. So it's equal to 1 minus 4, negative 3, square root of negative 3. See? So it's not right. So that's the equation of all. First of all, x is equal to 1. First of all, it's even out of bound. So you are deciding a solution that is not even in the acceptable range. So it's wrong. It's fraud. This interesting thing. If you go observe this step, if you plug in x is equal to 1 in this step, x plus 1 over x is not legit. But in this case, it becomes legit. So you can see that there's a sudden solution of x equal to 1 coming up. Like it originally should not exist, but it now exists. So just be careful about this one. Like this is something that may generate. It's weird, yeah. Okay, so the next thing. Positive negative roots. This one I just copied directly from Wiki. I think it's a quite interesting one. If you want to see what the original or what the original link is, try go to just give me a sec. Source http is in.wikipedia.wiki.mathematical fallacy. Let's see this thing. Negative 20 is equal to negative 20. 25 minus 45, because 25 minus 45 is equal to negative 50. And then it rises us 50 square, 5 square minus 5 times 9. And then you add 81 over 4 on both sides. In this case, it forms a perfect square, a minus b square. So in this case, you can get this step, and then take the square root out, and you get now 2. The problem actually comes from the third last step, which states that 5 over 9 over divided by 2 is equal to 4 minus 9 divided by 2. If you calculate it severely, it should be 0.5 is equal to negative 0.5, which is fraud, wrong. In this case, it could only be equal to negative 5 minus 9 over 2 is equal to 4 minus 9 over 2, instead of positive 5 minus 9 over 2 is equal to 4 minus 9 over 2. Yes, because this is the problem of the square root is that to reach the same results, it can be achieved from both positive and negative sides. For example, if we say x squared is equal to 4, the x can be positive 2, but it could also be negative 2. Now let's talk about the third fallacy. Can you spot the mistake between the two? 0 is equal to 1. 0 is equal to 1 minus 1. Blah, blah, blah. And then you plus 1. So the problem is that look at it carefully. Is the right side actually equal to 0? In this case, it's not. Because if you can see that in the second equation, it's 1 plus 1 minus 1 plus 1 minus 1 plus 1 minus. However, the third one becomes 1 plus 1 plus 1 minus 1 plus 1 minus. So you can see there is, no matter how far the equation goes, there is always one additional plus 1, then an additional minus 1. There's one additional plus 1. So in this case, the fallacy is because of the wrong intuition and the wrong interpretation about limits. Yeah. So here we come to the end of our lesson, and I hope you have learned a lot. See you next week. Bye bye.